Alright, so we're starting with number 5. In this problem, we're calculating the center of mass of the Earth Moon system, and then we're calculating the center of mass of the Earth Moon Sun system. The mass of the moon is, the mass of the Earth is, the mass of the sun is, distance between the sun and the moon is in kilometers. Ooh, right away I think I gotta change that to meters. Distance between the Earth and the sun is this in kilometers, and again I have to change that to meters. So they provide me with that little fun diagram, and I have to figure out the center of mass, and then my guess is other things also. So I'm going to start off with 2 diagrams. So this is number 5 here. I'm going to start off with moon, Earth, and then also moon, Earth, sun. Alright? And then let's see. I'm going to use we'd have this, which would be the radius of the Earth to the moon. I'm going to guess my center of mass is here. And then this be radius Earth to moon, radius Earth to sun. I'm going to guess my center of mass is here. That diagram may be off because I don't know if they're having it in that arrangement or the moon in between the Earth and the sun, or how they're having us arrange that. I know it'll be in a line, so it's either this or the moon in the middle there. We'll have to see. And let's see. I think I'll use the Earth. That's my point of reference. Let's look. Calculate the solution of the center of mass used coordinate system, which the center of the Earth is the reference point. Okay? So I'm going to use this as my point A, and my guess is this is going to be my point A over here. Yeah, those would be my diagrams for my Y. Let's see. I think I showed the situation. Both diagrams are there. All masses or forces shown. Well, I suppose I could say, oh, that's the mass of the Earth. That's the mass of the moon. Yeah. And labels on the diagram are easy to understand. We all know what CoM is and radius is. Any questions on the Y? Yes.
So is R the end of radius of the Earth and Moon?
Yep.
And then what is the point of, is it the point of reference, is A?
Yep.
What is it?
Well, in the center of mass, all the locations are measured from the same point, so they'd all be valid. So we always have a reference point. On every diagram that we've done up to this point, we've put a reference point, and we've labeled them all A. Why A? I don't know, but we have. We could have labeled them all George. Wouldn't have mattered. Yeah.
Right, the radius doesn't matter, like what you put first, like for Earth and you do farm.
You could do moon to the Earth, but it'd be the same, right? It'd just be reversed to each other. Yeah. And since it's only a location, it doesn't matter. What is what? Center of mass.
Oh, I thought it was
No, Are you making fun of my writing?
Uh,
I think you are. C-O-M. You're welcome. I thought the labels were easy to understand. I guess I got to sing myself a point for that. All right, well, let's do it. So now we're down to the how. Give ourselves a little extra space. And we need to start with our valid equation. This is part A. And that would be XCM. There's only two masses, so you have mass 1, x1, plus mass 2, x2, over mass 1 plus mass 2. Right? That's right from our equation sheet. I think I'll call mass 1 the Earth and mass 2 the Moon. So now if I was to do correct substitution, XCM, I don't know what that is. M1, this would be mass of the Moon. Oh, sorry, I said M1 would be the Earth. That would be mass of the Earth. And from my diagram, the Earth is 0 away from the set point of reference. Then this would be mass of the Moon. And it's R, Earth, Moon away. And then mass of the Earth plus mass of the Moon. Which I think are all given to us. Right? And so you can just plug in and now solve for XCM. The only thing we want to be careful of, we want to make sure that we look at what units are we going to give our answer in. And I'm going to guess that they're going to want meters. Nope, answer in kilometers, thanks. So I'm going to leave that radius in kilometers because that will let me end up with kilometers, right? Because if that's in kilometers and that's in kilometers, then that's going to be in kilometers. So I would just substitute in based on, they tell me what the Moon is, the Earth is, and then they tell me the Moon to Earth distance, which is the radius. I think you guys can do that math, right? Yep. And then once you have that, then you go on to part B. And you can answer part B based on your answer to part A. Part C, Earth, Moon, Sun system during a full moon. A full moon occurs when the Earth, Moon, and Sun are lined up as shown in figure 2. Hey, I set it up right. Wow, I didn't even know I was. And use the coordinate system in which the center of the Sun is 0. Express your answers in kilometers. So I have my diagram right. I just put my reference point at the wrong place. So since they've been specific, I would go back up here and change my reference point, my point A, to the center of the Sun rather than the center of the Earth. And then I do the exact same problem, which I'll lay out, but this stuff, did you have a question?
Okay, so when you're plugging in for the mass of the Earth, you plug in like the 6 times 10 to the 24.
Whatever value they said mass of the Earth is. Yep.
And then if you multiply by 0, does that just become 0?
Yes. Any number multiplied by 0 is 0.
Or you got it.
No, you're thinking correctly. And that's what's nice about picking the reference point to be there, right? You just made your math easier, which is always a bonus. So B is that multiple choice. Part C uses our same equation, this time with 3 things, so I'll rewrite it. M1 x1 plus M2 x2 plus m3x3 over the three of them. And I think I'll use the sun as the first one, so that would be 0 away from the sun. This will be the Earth, which, how far away it would be the radius of the Earth to the sun. And then the mass, the moon is the third one, which would be the radius of Earth to sun plus radius Earth to moon. If I look back at my diagram and I notice that I've got to go from the sun to the earth and then from the earth to the moon to get all the way to the moon. Over mass of the sun, mass of the earth, plus mass of the moon. Again, all values that you have, and I'm pretty confident you guys can plug in and solve. Yes, sir?
When you plug it in, could you put scientific notation?
Mm-hmm.
Could you write out standard with
I use the EET. Yep. I find I make less mistakes that way. Because one of the things is if you put into your calculator, let's say you did 5 times 10 and you did caret 5, and then you said, okay, I'm going to multiply that by 7. Okay. If you just write that, the only thing that's multiplied by the 7 is the 5. If you do 5e to the 5th times 7, that's a whole number, so it multiplies the whole thing by 7. You would have to put parentheses around this whole number to get the same correct answer. So that's why I do that. It's a lot easier to type 1, 2, 3 keys than 1, 2, 3, 4, 5, 6, 7 keys. But that's just me. But just don't forget those parentheses, otherwise you'll get an answer you weren't looking for. Anything else on this one before we see what else we should do? Good. All right. All right, so looking at number 6 here, you place a can of soup and a jar of pickles on the kitchen counter separated by this distance. I'm assuming that separated by distance they're measuring from center to center. Since they don't tell me any other dimensions of the cans or anything, it wouldn't be fair if that wasn't center to center. And they're asked what's the magnitude of force of gravity that the soup can exerts on the jar of pickles, magnitude of force of gravity that the jar exerts on the can. Ooh, what do I know right away about those two forces? Exactly, because they form a force. They're a force pair. So I'm going to start with that. The two forces must be equal in but opposite in direction. The masses attract each other through a grav force. The more mass, the larger the force. Is how far apart the cans are contributing to the force at all? Now, what happens if I move them further apart? It'd be less, right? You know, this is a great time to check your Y's, and if you miss things, add it in, or pat yourself on the back as you check off that you had things like this. Less force. See, does that hit the rubric? Clear understanding of the physics? Yep. Sketch the roadmap to the how. Ooh, I didn't really get that in there. How about I add in between the cans? Let's force between the cans. Because then at least I brought it down. I recognized that I read the problem. I didn't just slap some facts about gravity up there. Explain why the universe works this way, not how to solve it. Yep. Here, write me something else. Sorry, just noticed something. Good. And I might even do a diagram in this one, but I think I'll do my diagram in my how. So, got a can of soup. And a jar of pickles. And let's see, their soup is 0.12 kilograms. Pickles are 0.35. They're separated by right? I like my pickles. I'll have to save that diagram. So, let's see, for my equation sheet, I'd look up and I'd find, oh, I've got an equation for universal gravitation. And I have my universal gravitational constant, which nicely I have saved in my calculator so I don't have to type in every time. And I notice my constant is in newtons, meters, and kilograms. I know I want my answer in newtons, so I need to use my distance between the centers in meters and my masses in kilograms. Otherwise, I've got to do some funky unit conversions. So, hey, look, they're already in those. Nice. So now I sub in, right? .12 kilograms. Does it matter which one I put as 1 and which one I put as 2? No. You're not sure? Ask a math teacher. We can explain it to you. It's like the commutative property or something like that. Yay, and I just do my calculator work. Right? All right, so number 9 gives us a planet, Mercury here, gives us the radius in kilometers, but then gives us what they're calling the acceleration due to gravity, which is equal to the gravitational field strength. So when you're in a gravitational field, the gravitational field strength has the same magnitude as the acceleration due to gravity. And they give us that in meters per second squared. So already I kind of have a conundrum on units. I have kilometers and meters. And then what's the mass of mercury? And they want kilograms. So I'm thinking that I better convert the kilometers to meters, because everything else is standard units except for that. So we did one of these like these in the example problems. So that's good. But we're gonna remember, we're here, here's the planet. We're talking about the point right on the surface. So that would be the radius of the planet away from the center of the planet. Not a very good center on my part. But the mass of the planet, in this case Mercury, creates the grav field. The further from the center, the less magnitude the field has. And I suppose if you didn't do the diagram, you could also say, you know, when on the surface, you are one radius from center of planet. Right? And that's a little fact that shows you understand that they're not right on top of each other. Can I move forward? Is that good? You got that? Yeah? No. So, from my equation sheet, I would grab that gravitational field strength is big G mass of the planet over radius of the planet squared. And of course, from there I'd also grab the big G of 6.67 times 10 to the negative 11 Newton meter squared. Better to use meters than kilograms squared. And now it's, again, plugging in, right? I know little g, 3.7. Well, Mr. Cochran. Hey. Oh, okay. I thought Jess was just going to watch him from across the street. Okay, that's fine. No problem. Thanks. Bye. I'm going to put that in newtons per kilogram because that's the right units for gravitational field strength. Put in my value for big G. Newton meter squared per kilogram squared. They want to know the mass of mercury. Oh, good. And I put it over my radius squared, which that's in kilometers. So I need to convert that to meters. So I can do that 2,400 times 10 to the third meters. And then square, don't forget to square that. That will probably be the most common math mistake is to forget that square term. and then just solve for M.